In college algebra, we wrapped up 6.3 part 2. On Friday, we started this, looking at how to solve equations based on matrices and multiplying matrices. So number 2 we skipped. Let's go ahead and solve it here. You need to start by solving for x, and you do that by subtracting a from both sides. And then you know 3x is based on b minus a. So let's do that on the side. We have negative 10 minus 2, 1 minus negative 8, 0 minus, or sorry, I did backwards there, negative 9 minus 0, 17 minus 4. Looks like a weird 7. There we go. So, b minus a is negative 12, positive 9, negative 9, and 13. So we plug that into the equation. And we need to get rid of the 3. So we can multiply both sides by 1/3. And that way the 3's cancel out. And we're left with the answer. All right, let's move on to multiplying matrices. So down here we have a times b, and then we also have to do b times a. Back up here, I showed you a couple ways to multiply matrices on Friday. Here's yet another way. When you're doing a times b, you need to go row 1 times column 1. So that means this row times this column. And for the next spot in the resulting matrix, you need to go row 1 times column 2. And then you're done with row 1, so you move to row 2 times column 1. It's like each row of A has to move through each column of B. So row 2 times column 2. So down here on number 4, we get a really weird result for both of these questions. When we do A times B, there is only one row, and there's only one column for B, so we only end up with one number. We're going to go all of row 1 times all of column 1, which means we go 1 times 4 plus 2 times 5 plus 3 times 6. Because this whole row, row 1 times column 1, is all we have. So AB is actually weird but very simple. We have 4 plus 10 plus 18, so 32. And yet when we multiply B times A, we get something completely different. You would think it'd be the same, but it's actually very different. So I'm going to erase my circles I drew here. And it's weird to look right to left. You know, I'm going B times A. So I'm going to redraw matrix A. It's pretty small, I can do that. And this one, from B, it doesn't look like it, but we have 3 rows. And for matrix A, we have 3 columns. So that means for the first position, I go row 1 times column 1. So we go 4 times 1. Row 1 times column 2, that's 4 times 2. Row 1 times column 3. Now we're done with the 4. we move on to the 5. And the 5 has to move through all 3 columns of matrix A. So 5 times 1, 5 times 2, 5 times 3. We're done with the 5. Now row 6 has to move through all 3 columns. 6 times 1, 6 times 2, 6 times 3. If you're asking yourself, why did I add on the left, but yet I'm not adding on this one we're working on right now, it's because on the one on the left, we had multiple elements in a row. We had 3 numbers in a row. That means you have to add to get that one spot of the matrix. For the one I'm doing right now, B times A, there's only 1 number each per row. All right. Do a tiny bit of multiplying and you're done. We have 4, 8, 12, 5, 10, 15, 6, 12, and 18. And that is BA. All right, on to the back. It's pretty quick. We're almost done. For number 5, there's one of these that we can't work. It's mathematically impossible. So you got to ask yourself, where do the rows and columns line up? Here we have row 1 times column 1. 4 lines up with the 1, 2 lines up with the 0. Look at part B. Row 1 times column 1. That one's not going to work. The 1 lines up with the 4, 2 with the 1. These two have nothing to be multiplied times. This one is impossible. But part A is very possible. We're going to go 4, 2 times each column. So we go 4 times 1 plus 2 times 0. So that's row 1 times column 1. Then the 4 and the 2 move to the next column, and we go 4 times 2 plus 2 times 2. 4 times 3 plus 2 times negative 1. 4 times 4 plus 2 times 6. Now we're done with the 4 and the 2, and we're going to go 1 and 3 times each column. So we have 1 times 1 plus 3 times 0, 1 times 2 plus 3 times 2, 1 times 3 plus 3 times negative 1, 1 times 4 plus 3 times 6. Do a little multiplying and adding, and you're done. Looks like we got a 4, 12, 10, 16, and 12. So 28. We got a 1, whoops, almost said that wrong, an 8, a 0, and 22. And that is it. Maybe put brackets around it. And we're done. See y'all later. Bye.